Okay, in the homework for 17.5, let's start with number 2. Here f is given as this, and we want to find the curl and the divergence. So we have I, J, K. Okay, so we want R with respect to Y, and that's going to be x z squared. This is P, Q, R, minus Q with respect to Z is xy squared. R with respect to X is yz squared. P with respect to Z is x squared y. Q with respect to X is y squared z. P with respect to y is x squared z. Okay, so that's the curl F. The divergent F is P with respect to X, Q with respect to Y, R with respect to Z, and we get that. Okay, and that's all we have to do for number 2. Let's look at 14. We need to determine whether it's conservative. So if the curl is 0, it's conservative. So we have to just find the curl. F is 3z squared cosine y 2xz. Again, we can use this thought process. So it's going to be I, R with respect to y is 0, minus Q with respect to Z is 0. X with respect to R is 2Z. P with respect to Z is 6Z. Q with respect to X is 0. P with respect to Y is 0. Alright, that's going to be 4ZJ. That's not 0 all the time, so it's no. 16, F is EZ1X e to the Z. So again, okay, so this is the curl. We check the curl. We have I, with respect to 0 minus 0. So F is conservative. So now we have to find a function f such that the gradient of f is equal to what we have. So the domain of f is r cross r cross r, actually r cross 1 cross r, and it has continuous first partials, so we can use this process to find a function whose gradient is capital F. So again, let me write down f. We need this to be f of x. So that says f of x, y, z is e to the z x plus a function with respect to y plus a function plus a function with respect to y and z. Okay, now we take the derivative with respect to y, and that's 0, plus the derivative of k with respect to y, but that should equal 1 from above here. So k is, when we integrate that, we get y plus a function of z. So far f is x e to the z plus y plus a function of z. Now we take the derivative with respect to z, and we should get x e to the z from here. So that tells us that h is a constant. So our function is x e to the z plus y plus a constant. And the gradient of that is going to give us the original vector field. Okay, so that does it for 17.5.